Welcome to Applied Food Science and Engineering with Prof. Vigent. What is freezing point depression and how does it impact your food? Here is a happy little collection of water molecules, otherwise known as ice. How do we know they're ice? Because they're in a lattice that has a nice hexagonal relationship between the water molecules, and they're not moving that much. Also, they're cartoons. Regular water ice freezes at 32°F or 0 degrees Celsius. Here is a slightly more accurate picture of ice crystals where you can see that hexagonal lattice repeats many, many times and in 3 dimensions. Now, what happens if another molecule happens along? This ethanol molecule almost, but not quite really, fits in the lattice. What happens then? This funny-shaped molecule doesn't quite nicely drop into that hexagonal lattice. In order to trick the water into freezing anyway, with this funny-shaped thing in the room, we need to take even more energy out of the system. That is, we need to drop the temperature lower. Let's look at a practical example. We left this bottle of wine in the freezer for a few days, and you can see its temperature is 6 Fahrenheit, which is way below freezing for water. Wine can be thought of as a mixture of ethanol and water, so we can use this equation to calculate how low we expect its freezing point to be given the amount of ethanol in the ethanol-water mixture. Plugging in the fact that wine is about 5 mole% ethanol and a whole bunch of other constants, I calculate that assuming ideal solution, the temperature we expect is 22 Fahrenheit, where wine melts from solid wine back into regular wine. That is, when the ice that has 5% ethanol in it turns back into a liquid. Checking back in with the frozen wine that's been sitting on my counter and warming up for the last hour, we see we have lots of liquid wine in equilibrium with a little bit of solid ice. And when we measure this temperature, holy cow, it's actually 22 degrees Fahrenheit. It's not just ethanol. This same relationship works for pretty much any molecule that dissolves into water in a moderately small amount, like 1, 2, 3, 4, 5, 10 mole%. It's called the colligative property, and it's why doing things like putting salt on the sidewalk make it so ice melts in winter. It's also why ice cream has to be below freezing in order to really freeze. Thanks for watching!